Hey guys, my name is Dakshi Gupta and welcome back to my channel Code with Dakshi. So in this video, I will tell you about how can we recognize gender, male or female. So how can we recognize that this pic is of male and this pic is of female? Okay, so let's start. So for this project, let me tell you one thing guys, this project link is available in description and this project is available on Kaggle, right? So you have to download this project from Kaggle, right? So I will upload all the code part in my description, okay? So you can take help from this, and all the data of this project is available on GitHub. So in this project we have training and validation part, and these two part is very important, and we have hard cascade front face default also. In validation part we have male or female. In this we have all the pictures of male, and in this part we have all the pictures of female, right? So after this, in training part we have these, but we have target.numpy and data.numpy, right? So these two are very important in training part. So after this, let's start the coding, and readme file is also available. This is the empty file, right? So let's start. First of all, you have to import cv2 and import os. For this project, these two import are very important guys. Then data path equals to validation, as I told you, validation part, okay? So categories equals to os dot list dir of data path, which is validation. Then labels, label underscore dictionary, then print label dict categories and label, okay? We have to print it. Then as you can see, we have female 0 and male 1, and as you can see 0 and 1, right? After this, our image size is 32. Data, target, face data, as I told you before, is hard cascade, frontal face default, okay? So .xml, this file is of XML documents, so .xml. Then cascade, we have to run this, okay? So after this, for category, in categories, then folder path equals to os.path.join data path category. In this code guys, the main thing is this code, okay? For F in faces, like X, Y, W, H, V for V in F. Then I want to tell you one thing, why we are using resized, cv2 dot resize gray, then image size. Why we are resizing our image? Because some images are small and some images are big. As you can see here guys, like in male, as you can see here, the size of all images is different. Some are small, some are big, okay? So there are so many pictures guys, that like you can see here, this image and this image, then this image, all are different. All the size of these images are different, okay? Then for this we have to use resized equals to cv2 dot resize gray image size. Then why we are using except exception as e? Because we are using exception because in these, right, it may be we forget to use libraries, we forget to import the libraries. Okay, so for this we have to use exception, right? Then import numpy as np, import warnings dot filter warnings ignore. So in all the projects, guys, import warnings is very important. You have to import it, and warnings dot filter warnings ignore. Okay, remember this thing, guys. Then data equals to np dot array, then data divided by 255.0. Why we are dividing by 255.0? Because we have to convert our image into 0 and 1, right? Why? Because we have 0 and 1, 0 female and 1 male, right? So for this we have to use divided by 255. Okay, then data equals to np dot reshape, data dot shape image size 1. In this we have used here 0 and 1, right? Then from keras dot utils import np underscore utils. So if you are doing deep learning, you are doing TensorFlow, you are doing keras, you have to import first, install first. If you are getting error in keras, then you have to use pip install keras or pip install TensorFlow. Okay, sorry guys. Then new target equals to np dot utils, then to categorical target. Why we are using this line? Because it is used because to convert array of label data from 0 to -1. It is known as to one hot vector. Okay, so that's why we are using here this line, right? Then np dot save training data and np dot save target data. As I told you before, guys, we have these two in our training data set, so we have to use this, right? Training data and training target. We named it as data and new target. Okay, then how can this run? First of all, let me tell you, this is numpy file and py. So we have to import first, import numpy as np, then only it will run now. So import numpy as np, then data, as I told you, data np dot load, we have to load this data. So training data dot npy, it means numpy. Then target equals to np dot load target dot numpy. Okay, then our next step is create model. So we have to import all the things which are necessary for this project, right? Then number of filters 64, number of size of filter 1, 3 or 3, size of filter 2, 3 or 3. I forgot to tell you one thing in this, guys. In resizing image, the size is 32 by 32. Okay, why? Because our image size is this. Okay, that's why we are using this. Okay, so after this, size of filter 2, 3 or 3, size of pool 2 or 2. What is size of pool? Size of pool is used to reduce the resolution of the feature. That's why we have to use size of pool. Then no number of code, note, number of node, not code, okay, it's 64, right? So then model equals to sequential, then we have to add 3 things in this and 4 things in this and 4 things in this. Okay, model dot add con 2d. What is this? This is the number of filters that the convolutional layer will layer. Okay, so the size is same 32, then size of filter 1, then input shape, then activation of ReLU. Shape, why we are using shape here? Because we have to convert, we are converting data into NumPy, right? Because our data is of NumPy, right? So we have to use shape here, right? Then after this I want to tell you this part. Flatten, model dot add flatten. What is flatten? Flatten is used for converting the data into a one-dimensional array for inputting it to the next layer, right? So that's why we have to use flatten in this, right? Then model dot add dense number of code, then activation of ReLU, then dropout of 0.5, then dense activation softmax. What is softmax? Softmax is as the activation function in the output layer of neural networks models. Okay, then model dot compile loss categorical, then optimizer matrix, right? After this, from sklearn.model selection, import train test split. I think you have used this before. Okay, then train data, test data, train target, test target equals to train test split, then data target target, then test size equals to 0.1. Then our next step is to checkpoint. Checkpoint is the weight of the model. These weights can be used to make prediction as is or used as the basis for ongoing training. So we have to check our model. Okay, we are using here training model, then monitor, then history equals to model dot fit of train data train target. Okay, after this, as you can see, this is the checkpoint part. I know it's so long, right? After checkpoint, from Keras models import load model, then import CV2, import NumPy as NP, then model, our model is this right? Then as I told you, har cascade frontal face, then video capture, because we have to check that male or female, then label tick 0 male 1 female, then color is this. Okay, so after this, this is our main step. While true, ret image equals to cap dot read, What is detect multiscale? Detect multiscale is function which help us to find the features, locations of the new image. Okay, so that's why we have to use here detect multiscale. Then face underscore image is y plus w, x plus w, then resize as I told you before, divided by 255 as I told you, then reshaping result, then cv2, then this is all, then cv2 dot im show result image, this is our last step, then cv2 dot destroy all the windows, then cap dot release. So by this only we have the output will come, like our video capture will come, our system will do video capturing. Okay, so let's see the output. See guys, this is coming female. Okay, right, so I think this code will help you. Okay, I will share whole the code with all of you, so code is available in description, right? So please support me guys, please like my video, subscribe my channel, and please take care guys. Thank you so much.